Okay, now is for part 3 you have model something like a soap, like this shape, and this has length 110 millimeter and this length 80 millimeter. This thickness 40, and this also has radius in here. Don't forget 300, 500 radius in here. This also radius 30. Very complicated shape actually. But the first thing to do is you have to create the surface in here and also this surface. Okay, for next this part you have to insert geometrical set. We call it name sketches in here. Sketches and sketch 1 and sketch 2 you create in this geometrical set sketches. Okay, I will not forget this one. And first one, sketch. First, you draw on the XY plane with the radius 500 and radius 30 and radius 300 with the tangency from this line and this line. And the distance has the 40 millimeter and 55 millimeter. And for sketch 2, in this sketch, particular sketch, you draw on the YZ plane and draw something like this curve with the radius 100 and this tangent with this line. Okay, just leave it this part. You can save it, previous part, maybe name is part 2, whatever. Okay, close it and you create generative shape design. And don't forget sketch, insert in here geometrical set sketches, whatever the name is sketches, and also insert, or maybe later, just create sketch first. And first is sketch on YZ plane, XYZ and YZ plane. I think it's better make it like this, so I can see. Okay. Okay. I like create the axis in here. And the first thing to do, you create maybe using 3-point arc, very convenient. And this also, and create this 500. Can we move it this? Absolutely no. I can move this. This one 300. You can move it, I think. Yeah. Okay. And you have in here construction line at the vertical in this case, 55. In this case 40 millimeter. Okay, that is the beautiful. So just create another arc, and here this one is not construction, and this one is radius 30 millimeter. Okay, just make it this tangent. Make it this tangent. And this one should be coincident. Um, why it is not fully constrained? I'm curious. Oh, yeah. You should define this one also tangent with this line. And this also tangent with this line. So now this is fully constrained or sketch one. Very easy, right? Okay, exit workbench. Now this one sketch one like this. And we draw for sketch 2 on this plane. In this case, sketch 2, it has radius 100 and tangent with this line. Okay, go to position sketch, and maybe similar with the previous one, and you can create this arc. You can create this and this with coincident. Okay, and you can create this line vertical, and this one tangent with this uh, arc. You can create this construction line. So anyway, this one is a tangent with this line already. Can you see the symbol in here? If we see from the front, this one is tangent with this line. Okay, so that was is sketch 2. Very easy, right? And you need another sketch. Go back to PPT. Draw for sketch 3 with the tangent with this line. Distance is from here to here is 20 millimeter and radius 200 millimeter. And for sketch 4, draw on the ZX plane and draw with radius 150 millimeter and tangent with this horizontal line. Okay, I hope you don't feel boring. This class is very boring actually. And go to YZ plane, draw position sketch, Okay. For sketch 3, with the radius 200 millimeter. I make this line first. And this distance is 20. And the radius is, oh, this one become construction line. Okay. Circle definition, not important. Tangent. And the radius is 200. Okay, I'm correct. 200, and another is 150 millimeter. With the distance, I think is the same, 20 millimeter with this. I think this one is coincident with this. Okay. Create another sketch on this plane. This one is should be coincident with this. So I think this one distance is also same. It's about 20 millimeter. If you give in this for it's no need because you already constrain in here, and create the arc. Tangency. All right. So finish. So this curve is coincident with this curve. This point same. So this time is about 20 millimeter is same. And I think this one is finished for sketch. Okay. The next to do, you have to create geometrical set name wireframes. For wireframes, you create the extract again. Sorry, using extract again. Namely, extract 1, you select this curve, tangent continuity. Okay, and this extract 2, this element, tangent continuity, propagation type. Okay, for extract 3, select this element, similar, tangent continuity. Extract 4, select this edge, same tangent continuity. Okay, that one is for wireframes. So select insert geometrical set. We call it name is wireframes. So you create another this wireframes using extract. Excuse me, what is the selection has failed? You can select subelement or solid volume. I don't select anything. Very strange. Okay, so just leave it this warning, maybe is okay. Empty selection. And that one is for extract one. This profile and extract two. Tangent continuity. Propagation. You select tangent continuity. Select this element. For extract 2, extract 3, select this element. Okay, extract 4, select this element. Okay, am I correct? Yeah, this one 3 and this one 4. Okay, the next is very easy. You have to select this, so insert again, insert geometrical set, name surfaces, and which appear in here surfaces in the tag tree. Okay, and after that you select icon sweep. We create a sweep one. The type is explicit, this icon, which is the with reference surface, with the profile is extract 2. This is a profile. This one is extract 2, and guide curve is extract 1. This guide curve. Leave it another is default. I think this one is easy for you. So insert another, namely surfaces. This one is wireframe, leave it surfaces, and you create explicit with reference surface, which profile is the profile is extract 2, guide is extract, sorry, guide is extract 1. I think leave it default everything. So you create this surface. Okay, and this one is for surface, namely sweep 1, and create another sweep 2 with the profile extract 4, guide is extract 3. This one is profile. Okay, this one is guide curve. Create this like this. Leave it everything is default. Type is explicit. This one is explicit with reference surface. Okay, I think it's very easy for you. So with reference surface, and select this one. You can maybe you can hide this sketch. Okay, this one is profile, and this guide curve, select extract 4. Okay, this one you create a surface something like this. It cross each other. Later we create a trim for this surface. Okay, let's just up here again. Close. After that you create the trim one, which is the delete this side and this side, and remain surface is this. Okay, I think this one is also very easy for you, and you can hide the wireframe. No matter, we don't need anymore. Select a trim in here, and you select this sweep 1 and sweep 2. and you look at which part you are deleted. This one is not this part, so you create something like this one and another side, this one. So this one will be deleted. This one is remain. Okay. Okay. This one is remain surface. Trim. Okay, for village, or what is move automatically. For trim, sorry, not trim. For edge fillet, variable fillet, select this edge and select the point, and you give the point in here value for radius 10 millimeter and for in this case 15 millimeter. Very easy, right? And the result is like this. Okay, I think it's so easy for you. Go in here and select this icon variable fillet, which is the 10 radius for this and this. This one 10 radius, and element for in here is select 15, and also in here select 15, 15, 15, and in this part you select 10. So this one very easy. This one 10, 10, 15, and 15. Okay. Now you have profile of like this. Very easy for you, not complicated. After that, the rest of the method is just symmetry. This one and join, and then also symmetry, and also join, symmetry, and also join. And this one is final product. And the last is cross surface for part body. Where is symmetry? This one is symmetry. Select this symmetry with the reference of this plane. Okay. And then you can join between these two surfaces. After join, you can symmetry again. Join one, and this reference is ZX plane. And you should join again. This one. Okay, after join, you go to symmetry again. Select this join and select this again, and the last is join again. This surface and this surface. Okay, this one is a final product for this part 3. It is we have a sketch in here in geometrical set, and this also our wireframe extract from the sketch, and we have a surfaces in here. Okay, you can hide this, and the next is go to define inward object part body, and go to part design, and go to close surface, and select the surface is join 3. Okay, you can hide this, and you have this solid model closed surface with this kind of type of solid based on the surface you have created. Okay, Very simple part, right? You can save it. Name is part 3. Okay. This one end of part 3. If you have any question, you can contact me. I think you are able to create this. I think it's very easy for you. Okay, for part 4, for last part, we are going to create a fan. Create fan like this. I think this one is not complicated design. And in this fan or propeller, whatever, and this you create in here this surface and using thick surface. Later on, this has thickness 2, and this one from here to here is 5. Maybe you can create by using helix in this case. And this one is in this part, maybe you can create using solid feature. Is I think it doesn't matter. Using pocket is no matter. I think it's fine. And this also has fillet edge radius 2 millimeter. Okay, I think it's very simple. So the next to do to make it structure of type 3, I suggest create a geometrical set, namely sketch. Sketches. Okay, so close this one. So we have the namely sketches. Sketch for sketch, and this one is also wireframe. And also has surfaces. To go sketch, you can go to work in define object. Okay, you want to create a sketch first. And in this sketch, we have we want to using the revolve. This revolve. So for revolve, first we have to create sketch 1 and sketch 2. And the next is using extract for wireframes. Extract point continuity, and the second one is no propagation. This one is for wireframes. Okay, and the next, go to surface and define in work object, and just select the profile for extract 1 and extract 2 you have created, in this case from previous sketch. Okay, let's do it. For the sketch 1, I feel you don't feel boring, you can listen music. I think this one's class is, I think, very boring for you. I hope you can follow me and you can understand what's going on. This one is create a line like this. Okay, this one is can move it. Okay, just give dimension 50 millimeter. Distance from here to here is about 25 millimeter. The height you have in here, the height 15. Oh, great. What happened? 15. This one is for sketch. Okay. And you can exit. This one is for sketch 1. For sketch 2, same plane. You just create and line. Just line for axis rotation. We just practice using extract in here in this case. Oh, sorry. Define in work object. Go to point continuity for this extract one, and you have this one extract 2, same profile. So if you hide this, it's the same profile with sketch 1 and sketch 2. Okay, that's the we just practice using extract in this case. No matter. And you can go to surface and define in work object. Now step, we already done this one. Insert surface, okay, we already done. And go to revolute. For profile, this profile, select extract and revolution axis, extract 2. With the angle is same, equally 180 degree. Okay, you can hide wireframe. Okay, this one is just simple cylinder. We create a very complicated using geometrical set. Actually, you can create directly using sketch 1 and sketch 2 is no matter, no need extract. We just practice in this case to make it more beautiful tag 3. Anyway, for the next step, select wireframes and right click define in work object. This wireframe, right click define in work object, and in this case create a point, and distance is -20 and 15. After create point, you can create helix. In this case, helix using point 1, which I have created in wireframes. In here, point, select this point, and it has pitch about 120 millimeter, in height 40 millimeter. You already know helix previously. We already know we create in gear in previous lecture. In gear profile, we learn how to create helix. Anyway, very easy. And the orientation counterclockwise. Okay. Go to wireframes and point. coordinate. The height is I forgot. Minus 20, 15. Height is 15 millimeter. So you create this point. Can you see? I will make it bigger for you. This point. You can. Oh, oh, what is happened? I create 2 points. I not need this. You can hide this wireframe. I think no need. Okay, you can create this point already. And now you go to helix. Okay, create helix in here. Starting point is this point. And axis is y-axis. For pitch 120 and height is 40 millimeter. Okay, you can see this one is helix. Profile counterclockwise. Okay. Okay. After this, you go back to PPT. Wait a minute. Something problem with my mouse. Sorry. Helix. Okay, done. And now select surface, define in work object. Go to sweep and profile line. Helix for guide curve and reference surface is revolute 1. And the angle is 90-degree angle perpendicular from this surface. Okay, it has length about 85 millimeter. Of course, because we want to create radius 100 in here, so 85 plus 15 become 100. And length 1 is another surface for inside diameter in here, 10 millimeter, just little. And spine, helix 1. I wish you don't have any problem to create this one. So profile type is line with reference surface, guide curve, helix 1, reference surface, revolute 1, angle 90-degree, and select length 110, length 2, 85 millimeter. So let's begin. Select this line, profile type, and select with reference surface. In this case, for guide surface, this one, helix, I'm sorry, you have to go this surface define work. Okay, and then go to again sweep. Okay, many options in here, but we select this with reference surface. Guide curve is helix, reference surface is revolute, and angle is 90-degree perpendicular. So for length 2 is 85, this one just 10. This one is default. Oh, very interesting. Why we go there? This line is a reverse. Hmm, this one very interesting. Maybe you can change this direction. Can we change direction? How about if 10 is 10? Hmm, that's is problematic. If I select this, change the direction of a length 1 and length 2. Previous, not this. So in my case, I very interesting. Anyway, you create a shape like this, with this length is 85 millimeter, and in this case, previous 3, but this in this case 1. No, this one is correct. Yeah, this one is I think correct, or profile. Okay. Okay, that one is sweep. Okay, for the next job is you have to cut this shape, and we draw sketch on here. Uh, and select sketch, right click, define in work object. We just practice this one and create a new sketch 3 in this and geometrical set sketch 3, and go to project 3D element, and you just select this line, and this project the line of this curve, something like this, and you can select construction standard element for this line. Let's become dot line, dash line I mean, and you can create using 3-point arc with the constraint in here, tangency and coincident with this line, remember, and this one about 40 and 20 radius. Okay, so in this case I think very easy for you. Okay, axis vertical and horizontal remain the same. So is in 2D sketch workbench, select project 3D elements. You can select this edge and this edge. Again, select again. Okay, this one now yellow. Oh, sorry. You can change it, become construction line. Construction line. Okay, now it's become construction line for each. And now you draw the this one, this case not construction. $20, and this is relationship is tangency. Is it coincident with this? I hope so, coincident. I cannot move this. I wish that one coincident. Otherwise make a problem. This one should be coincident. What is symbol? Can we make again? What is this? Is it construction line? Okay, I make it. I hope this one coincident. So can move in here. So this one is along this line. Okay. So just make it. Just make it relationship. This and this line is tangency. This line and this line is also tangency. Okay, now this line is tangent. You can create a stupid dimension. Please, I want to delete you. Stupid dimension, really. This one is 40 radius. Okay, after draw this, you can create a surface by extrude and cut the sweep surface. Okay, this one is basically your arc. Oh my god, this one is sketched in. Can I move in here? Oh no, impossible. That's the problem. I have to go here, define in work object. I will make again, no matter. I will create again. Oh, something weird. Okay, this one. This one is construction line. This one. This one also construction line. After this, I will create again. No matter. It's construction line. Tangent. Tangency. This diameter. Stupid dimension. I want to reduce, man. Like this. Okay, you draw another radius. I hope this one coincident. This one coincident, right? Now select this tangent C. Sorry, should be drag out. And you select this one radius 40 millimeter. Okay, now you have done here. You cannot move anymore. This arc, I hope so. This one coincident. Can you see the symbol is? I'm not sure with this one. This one, oh, this one is not coincident. Okay, this symbol O is coincident, 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 and coincident, and also tangent. Oh, good. So this one sketch 4, it should be sketch 3. I make a mistake. I change it the name. Sketch 3. Anyway, after this one, you just go to surface and work in define. In here, go to or you in this PPT. Actually, I make the multiple extract one for wireframes after you create the sketches and select this element. But I think this one also. Anyway, I just make a practice for you. Okay, go to wireframe first and multiple element. What is that? I don't get it. This one is not connected each other. Maybe there is something of warning. Okay, anyway, this one is multiple extract one and go to surface after you create wireframes. Extrude. Profile is for multiple extract and the direction is Y component is about 40 and 40 millimeter. Okay, you create the extrude. Okay, multiple extract and extrude. This one multiple extract one by direction 40 and 40. Okay, after that you create the split. Element to cut is sweep one. You delete this part of surface by split. And this one extrude cutting element for cutting element of this surface. And you can next or hide or show the extrude one surface. And this one is not trim. Split. I hope I success for this one. Yeah, you can delete this. Sorry, I want to rotate. Very hard to rotate. Can you see this one? This surface is deleted anyway. Okay, now you have a final shape of the propeller or fan. Okay, you can hide in this, and there are multiple extract also can hide, or sketch you also hide in here. Now you have final shape of the how to say blade. Anyway, next is select part design and part body. In this part body, define in work object. And first is you create closed surface and select the object to close is revolute 1 for surface on this cylinder, of course. And the for blade, for this fan shape, go to thick surface and select the split 1 for this kind of type of shape. Okay, offset is 1 millimeter and second offset is 1 millimeter. I hope you don't feel boring with this class. And go to part body, define in work object, and you can see this one is underlined and it means the part body is active. And go to part design. In this case, go to close surface and select this revolve surface is this one, right? And you have this one close surface of revolve. If you hide this revolve, you have the solid body of revolve. And select the thick surface, and object to offset is a split final surface of this one, split 1, and this one 1 millimeter, 1 millimeter. You can preview, and this one is solid object of your blade. Okay, after that go back to PPT. You can go to edge fillet first, about 2 millimeter radius. You can hide this wireframe and go to this edge fillet, which radius 2 or 1, 2 millimeter. And I hope I success create this. Select this edge and select also this edge. Okay. Okay, now you have this kind of blade. You can hide the surface, absolutely. It's nothing to do anymore. And after this, you can just go to circular pattern. And circular pattern, complete crown tree, and select the current solid reference element y axis in here. Okay, and surface can hide, no matter you don't need surface anymore. Okay, the rest of this particular model, you just create this keyhole, and I think not keyhole, just draw is like this sketch, namely sketch 4 on this plane, and just go to pocket and up to last or up to next. It's very simple. And the last thing, you just draw another sketch, and in part body, define in work object, go to pocket and the depth of 10 millimeter. And this one is final product of the fan, of the propeller, or final product in our class. So just go to circular pattern, complete crown, 3, axis rotation is z-axis, get the current solid. So this also radius, also join this radius h. Okay, this one is shape of your fan. What is this? Okay, this one is type of part body. This one circular pattern active. So just go to define in work object, go to sketch. In here, select this plane. Okay. And you draw this one based on this. This one I have 14, radius 5 or 4. I think very simple. Radius is 5 and you create a rectangular, center rectangular. Click this. And 4 millimeter, and this one dimension is 14 millimeter. And you just go to quick trim. Come on, what is that? I think I should buy new mouse. Okay, this one is 4 millimeter and this one is 5. Okay, you just exit and go to part body and define in work object. Go to pocket and go to up plus. Surface selection is sketch 5, or I will rename it later. Okay, this one go through for the back, from front to back is fully pocket. Okay, this one is should be, I do mistake in previously sketch 4. Anyway, the go to sketch again, define in work object, and go to this. I'm sorry, select the surface, position sketch. That is very stupid. I don't make a dimension. Dimension is about 10. I don't remember. Let's check this. Yeah, 10. Radius 10 and this one also 10. So our job is done. And go to part body, define in work object, and go to pocket, select this, sketch, go to dimension, go to 10 millimeter. Okay, anyway, you can delete this. not delete, I mean hide. So this one is final product of fan. As you can see in tag 3 in here, very structured tag 3, you have the solid feature. This one is all solid process. Cross surface, thick surface, edge fillet, circle, pattern, pocket, and you have also geometrical sketches. Maybe I have to rename it this one. Sketch 5. Sketch 4, 5. You can hide or show our sketch in here. And also you have a frame. This one. The frame is similar with the sketch. And also helix point. You can hide it. And also you have a surface in here. This is a revolute, this surface, extrude, this one, split. Anyway, you can hide this all in instance. So this one is practice using the geometrical set. Okay, in here you have sketches, wireframes, and surfaces. Categories of all very structure, and just make it become complicated actually. Anyway, yeah, finish our lecture. And you have the homework, of course. Homework 5. It's make it same fan but a different dimension. And this one I think is similar length, 50. Length is the same, 50, and helix and pitch is remain the same. I make it the same, 20, 120, and 40 millimeter height. And this one keyhole is slightly different, and also the shape of this blade also slightly different with radius 10 and this one radius 20 millimeter. Okay, I wish you can make it this model. I think this one is very easy for you. We already learned, and thickness also same, 2 millimeter, and this one has fillet radius 5 millimeter. Okay, this shape also same, but this depth is different, 20, and the radius of this one is about 45. This one is 45 millimeter. Oh, you cannot read this. Very ugly. Okay, only one part for homework 5. And thank you for attention watching this video. I hope you don't feel boring and have a good day. I will upload this homework for in the system. Thank you for your attention. Have a good day, and I hope you success create this fan. Thank you.